to the Landskrona Commission.
Okay, we're going to talk a little bit about the city where we are about to build. So Landskrona is a city in southern Sweden, once eastern Denmark actually. And it's a quite charming and beautiful city located at the shores of the Öresund Strait, which is the entrance to the Baltic Sea.
That's better.
And the city was founded in the early 1400s by the king, Eric of Pomerania, who was king over Denmark and Sweden and Norway at the time. And the city was founded in Denmark. Okay, so the city was... I'll do like this. So the city was founded in the early 1400s in Denmark. But this was a contested area. So the Danish king, Christian III, found it expedient to build a citadel or a fortification, which you can see here to the left. And this citadel still stands and still completely dominates the aerial view of Landskrona. And this image is from 1676, and Landskrona is now Swedish, and there are about 700 inhabitants. So fast forward 200 years, this is from 1850. The citadel has lost all its military importance. But the city is now growing rapidly as an industrial city. And it has about 4,000 inhabitants. And this is an image from today. And if you want to capture what it really looks like, you can see it as being in a sort of petrified transitional state. So if you imagine a small town with consistently small houses aiming towards becoming a large town with consistently large buildings, and you stop this process halfway, you get something of Landskrona's nature. It's a very charming mix of large and small buildings and various building types. And Landskrona, as of today, has about 33,000 inhabitants. And here you can see an aerial shot. So you can see Denmark at the horizon, and then you can see the island of Ven out in the strait, and then you can see Landskrona. And you can also note that the terrain is almost exactly flat.
Yes, and the city of Landskrona tried 3D modeling. They wanted a 3D model of the city. So they tried 3D modeling for years by themselves. However, they did not succeed. One reason that they failed could be the state of the computer equipment. Or it could be that they indeed have somewhat more up-to-date computers in another room, but that good 3D modeling is hard. So what did they do? They made a public national procurement in the late 2017, a procurement which we at Holygon won. So they gave us input data, and we designed and 3D modeled the whole city, digital city model, and then sent it to them to have it printed. We also designed a table for it to stand on. The whole process of our process of modeling, from input to final delivery, was 3.5 months. Now, we didn't want to commit the same mistakes as others have made. So here's a mini presentation, the fumbling city, misdirected urban modeling for 3D printing. So let's avoid those costly mistakes. Is there a one-click solution? Say you've got a point cloud. The dream would be to click a button and then get a city out of it. And it is indeed possible, and this is what you get. This becomes very quickly an indiscernible lumpy mass which ties the eye. This is a sort of holy grail within digital city making. So there is much research going on here in this area, but there is no satisfying solution. Why? Computers are stupid. They lack the interpreting intelligence that is needed to make a good city model. They cannot create aesthetically meaningful choices. So in sum, automatic generation makes you unhappy. You need to do many things manually, but some you can do automatically. Here's another city model. This is Birmingham. This is obviously 3D printed and 3D modeled. It's colored, but perhaps not so very thought through. It has a certain lack of unity, and there is, I don't know, a bureaucratic and perhaps even joyless character here. You can't really tell what is a road and what is a waterway, and so on. Yet, this costs a lot of money. And the third example, it's Malmö. They're using the same 3D printer as we are. Note here, and their geometry is somewhat better, but look how they have, what have they done with the textures? The materials are functionally unseparated. So visually it's unhierarchical, and it becomes sort of a mulchy mess. If you look close, the details may or may not be right, but if you look from a distant overview, it's unreadable. Why is that? They've taken probably fairly good 3D geometry, and then they've draped aerial photography on top of it. Satellite photographs and perspective photographs and so on. And that makes it hard to read from a distance. Whereas they should have made a map, what is functionally a map. So, in sum, bad models are just as costly as good models, and a city model is not the same as a city model. So, what's our approach? What is a good city model then? There are some technical criteria. You need empirically correct geometry within, say, a decimeter, depending on the input and what the client needs. The output needs to be 3D printable, i.e. all solids. And the parts need to be individually replaceable if you're making something that consists of several prints, as we did. What's this? This is a traditional hand-drawn 2D watercolor that we made for another client a couple of years ago. This is no city model, but it's a starting point. What we're after is a sort of effortless visual navigation, yet containing fascinating details. Discoverability. So it should neither be too cluttered, as we've seen, nor too sterile, as we've also seen. A good model speaks gently. It doesn't scream, and it doesn't whisper. It speaks gently. So colors are really important here when it comes to design. Judicious simplification is the way to go, and embrace some sort of mild idealization. That makes it readable. Plain, untextured colors work best, that separate functions, yet unifies the whole. And most importantly, perhaps, functionally, a good city model should be a map. At least as the bigger it gets, the more important this is. An aerial photo, draping such stuff on top of a 3D city model, makes for information overload, whereas a map helps viewer interpret what they see. So do think whole first, and make the details serve the whole. That is what makes a site of interest.
So in order to create a city model like this, you need some high quality inputs. And the municipality of Landskrona, they were providing us with some really supreme quality inputs, which made our lives quite a lot easier. And the first input is a digital elevation model, which you can see here. And this is just a regular grid with equally spaced points. And each point has a height. And the source had about 0.5 meters resolution, and we ended up using 1.5 meters resolution, and we have about 8 million points in our terrain. And the second input is high quality top orthographic photographs. So this is 44 millimeters per pixel, and it's really true top ortho, which in SketchUp parlance means it's parallel projected. And this is very important because you can use this photograph to trace out various stuff, and this will then mesh perfectly with the other data sources. So the fact that it's top ortho is really, really important. And we also use this photograph to sample the roof colors, which we will use in the model later. And here we have the third input, which is a 431,113,425 points point cloud. And you see just a little chunk of it here. And this point cloud is obtained with a drone, and you have a small laser scanner on it, and it shoots out small laser pulses. And you measure the time it takes for the laser pulse to bounce back, and then you get the point in 3D space. And in addition to these three main data sources, we also used old photographs like this. We used facade photos and also our own observations. And here you can see the point cloud overlaid. And the data sources are they are over 100 years apart, but it's still a snug fit. So, but input is not enough. You're also required to produce some kind of output. And in our main modeling workflow is that each input gives rise to an independent modeling track. So in the end, we end up with the 3 master models. And these individual tracks, they have synchronized coordinate systems and so on, so we can just paste in place between them. And we model in 1-to-1 scale already from the start. And the first modeling track is the terrain. And this is the final state of the terrain. And as you can see, the model will be circular. And it's 1.6 kilometers across here. And in the end, we model in scale 1 to 1,000. So the model will be...
We don't model it. We export it.
Yeah, we export it or print it in 1 to 1,000. Yes. So in the end, the model is 1.6 meters across. And the terrain as we received it was really excellent, but there are bound to be some problems, especially along the coastlines. So here we can see a close-up of one of the moats surrounding the citadel. And what you see in the middle is water, and you can see the vertices on the water. They are extremely jagged. This is just an artifact from the terrain model, because when you have steep sloping terrain in a regular grid, you will get these directional artifacts. You can also see some other directional artifacts higher up in the terrain. But we had to fix this, and the way we did was we wrote an extension that takes all the points lying on the water surface and adjusts them to the red lines here. And the red lines, they are idealized coastlines that we got from the orthophoto. And this was actually very important. First of all, because those artifacts are visible in the print, even though we print in scale 1 to 1,000. But even more importantly is that we do not want to print the water with the rest of the model. Instead, we want to make a cutout into the terrain to be able to insert water of another material, like acrylic glass. So we really needed very smooth coastlines in order for this to work. And to fix the other directional artifacts higher up in the terrain, we employed very careful smoothing. So we smoothed the vertices. But you have to be careful, because smoothing is basically lessen the difference between adjacent vertices. And if you do that too much, the terrain will completely lose its distinctiveness. So conceptually, what we did was we only smoothed vertices connected to 2 visible edges in this image. And in that way, we only smooth where we need, and all other vertices are left as is. And this is the result. There are still some directional artifacts visible, but they're not visible in the final print. So we were quite happy with this result.
The second production track, and do note that these production tracks are independent. So one guy can work on one, and another guy can work on another track. And then in the end, you paste in place and can make a master model. So ground types. You start by picking a number of ground types you find represents the entirety well. So we had about a dozen ground types. So that's stuff like grass, curbs, roads, gravel, reed, and so on. And these were traced by hand on top of the orthographic photo that we showed. And it's all 2D. More vegetation, still second production track. Here are the trees. You model an arboretum of a number of tree specimens. We used about 40 different. And we use them as components, of course. And then you individually place each tree matching for position, size, and type. The master model has about 5,600 trees.
Okay, and finally we have the gigantic task of extracting the actual buildings. And what you see here is a screenshot from SketchUp of exactly what it looked like when we extracted the building. So you see color by layer. It's a typically sized point cloud. It's a city block. It's about 500,000 points, 500,000 points. The resolution is about 50 points per square meter, which I think is about 5 points per square feet. And you can also see that the roof points are black and the facade points are blue. And we got a pre-classified point cloud, so we could import these classes independently and then assign layers to them in SketchUp. And this differentiation is actually very, very good to have. You can see the green faces, they are roof planes or roof faces that we have already extracted. And you can also see that there are not many points above or around these roof planes. And that is because when we have extracted a couple of roof planes, we just select a big chunk of points around them and press the M icon up there. And then all points within a certain distance from the planes are moved to an invisible layer. Because, and this is important because in point cloud modeling, visibility is really king. And finally, we have the red faces there, and they're just property borders from a municipality map. And these were important because when we extract the roof planes, we can already in the extraction phase tell our tool to limit the extent between the two adjacent borders, for example. So we get correctly sized planes already from the start. And at the top, you can see our award-winning icon set. These icons are made in MS Paint, but even though they look quite crude, and we wrote this tool set during the project. So even though the icons look quite crude, the tool set in the end became extremely refined, actually. It was also very fun to write this project because it's seldom that you have such a tight feedback between writing a tool and using a tool.
Yes, so, this is how we work. When we get a task that we can't solve with the native tools, we write our own tools.
Yeah. And also the extraction of the roofs was considerably faster at the end of the project than at the beginning, and that was because we constantly refined this toolset. The toolset is basically divided into four different functions. So the first icon, the L, is just load the points into memory, but then you have 11 icons for extracting roof planes with various constraints. Then you have 6 icons for adjusting these roof planes, and then you have a couple of auxiliary tools, for example, a chimney tool. So you just select a couple of points and you get the chimney solid automatically. And then finally, you have 4 tools for solidifying these two-dimensional planes.
So we'll take questions at last. Sure. So we'll get back to that.
Okay, so here we have a point cloud. And what do we want to do here? We basically want to reverse engineer the architect's SketchUp model. So the architect's SketchUp model contains a lot of roof planes. So we know that these planes, they are embedded in the point cloud somehow. It's just a matter of extracting them. And in this image, you can see all the roof planes extracted. And I mean, extracting a plane is not very difficult. You just sample a couple of points and then you estimate the best fit plane. But you have to be very, very careful because, for example, if you have a saddle roof and you sample the plane for one side and then you independently estimate another plane for the other side and then you intersect these two planes, you will end up with a ridge which is almost certainly not exactly horizontal. So you will get an almost horizontal ridge. And if, for example, this saddle roof then extends beyond a corner and you repeat this process, you will get a new ridge which is almost horizontal. It's almost at the same height as the first ridge, and they almost join in a common point.
That sounds almost good.
But it's not, because this geometry is almost impossible to fix. So the way to make this, this fly is that you already, when you extract the planes, you impose external constraints. So for example, we have a saddle roof tool, so we sample a few points from one side and a few points from the other side. And then we extract 2 planes, but we force the ridge to be horizontal. And we can force things like the height of the ridge, the direction, symmetry, whatever. So we had 11 icons for extracting roof planes. But we basically have just 2 tools. Either we extract a saddle roof or a single plane. And the 11 icons, they're just the number of useful permutations of our external constraints. But the whole point here is that we already, at the earliest possible stage, force the geometry to add up. So we get very nice geometry very quickly from the point cloud. So we have a couple of roof planes. And we want to solidify this to get 3D geometry. And the solidification process is that we solidify one roof plane at a time. And we also want to model these roof overhangs because we want these subtle shadows along the roof. So the way to do this in our tool, and to the left you see the input, and to the right you see the output, and normally they are on top of each other. We've separated them here for visual reasons. But the tool is very simple. You select your roof planes, it becomes red. You select an edge where you want an offset, and then you select the corresponding edge on the wall, which is blue there. And then you just press, I think, Shift, and you get the result to the right. So we get between 2 and 4 solids out of this process. So we get a roof solid, we get a building solid, and optionally we can get a cornice joining these 2 pieces. And this is a rather quick process, but it's a lot of clicking because we have a lot of roof planes. But it works very well actually. And here you can see the final solidification. But I should actually also say regarding the point cloud tools that there are 2 things very native or core to SketchUp that we actually want to avoid. And the first is stickiness. And the way to do that is when we extract the roof planes, we just embed them in a group so they can be adjusted independently. And the other thing we want to avoid is the dependence on modeling axis, because in a late medieval city like Landskrona, there is no such thing as a right angle. The general outline of a city block is 4 edges, none of which are parallel or perpendicular. So if you're dependent on the modeling axis, you may, for example, align your axis with a ridge, but then your gables will be off in 2 different directions. So it's extremely tedious. But when modeling in point clouds like this, you basically get independent of the modeling axis because all the directions are already embedded into the point cloud. But nevertheless, this is what it looks like after we have solidified the roof planes. And you can see we do not have much facade details, and that is because we do not have the data, and we didn't really have the time either. So we're very dependent on having very detailed roofs because these dormers and chimneys and terraces and stairs, they all provide a sense of scale. And if you remove those details, it would be almost impossible to tell the size of the building. And all those details, they also provide some life and vibrancy in the model. And here you can see the final building overlaid with the point cloud. And here we also color the roofs with empirical colors from the orthographic photo.
And here is the city hall overlaid with a point cloud. So to simplify the process, solids are generated from faces, and faces are generated from the point cloud. By the way, the physical model is right there on the ground plane there. It was inaugurated exactly two weeks ago, to the minute. So, in order to make this project fly, there were some workflow challenges. One is empirically correct buildings and roofs. That is probably the hardest part. And another is the sheer size of the model. So necessitating bulk operations on tens of thousands of groups. So the workflow in Holygon relies heavily on proprietary scripting. So there is something we can't do in native SketchUp. We write a script and make it happen. So for this particular project, we wrote about 45 scripts. Some were big ones that we used all the time, and some were just one-shot snippets that you use once, but may yet save you a couple of days of work. So there are some semi-automatic parts to the workflow, but it's really labor-intense. So, according to, if you want to 3D print it, you need a solid. So what is a solid? A solid is a watertight body without gaps and without overlaps. So for a simple, if you group a simple mesh in SketchUp and you select it in the entity info, it will tell you whether it's a solid or not. And if it isn't, you may use Solid Inspector 2, and it can help you with a lot of problems. And some problems you just have to solve manually. But geometry in and by itself does not want to be solid. So it's a little bit, forcing everything to be solid is a little bit like riding a bike that's constantly toppling over. So you need to keep that in check. There is also specific printability. So our client in this case used ProJet 660 Pro. It prints in stucco. So I don't know if you've seen, but down in the Knowledge Cafe, there are some samples from the big model. You can get a feel of the material. So what is stucco? It's gypsum powder, a slime, it's binder, and it's color. So you want to make sure that the things that you're 3D modeling will survive printing. And about the only change we made was the thickness of the trunks of the trees. They needed to be thicker than they really are in order to survive printing. But otherwise, almost everything has the same dimensions as they have in reality. There is no 3D color printer that can print the whole thing in one go. So you need to slice up the master model into smaller pieces and make them one by one and send them off to the client. So that's what we did. So either you can take the whole model and slice it up with a rectangular grid, as most people do, but we chose not to go that way, because if you do, you get the unsightly seams, and the seams can go right through buildings or right through trees, so half the tree gets cut off and so on. Instead, we manually drew lines between the pieces so that each piece fits in the printer's printing box, and we cut along roads and waterways. And that way you can hide those potentially ugly seams. So we've got a master model, or 3 master models. We've made this map of all the 40 pieces, and now we need to make the pieces themselves. So one piece that we can, or 40 pieces that we can export and give to the client for printing, or the printing service.
Okay, so this is what it looks like in one of our master models. It's the ground type master model. We have piece 11, or the polygon for piece 11. And we have this polygon clipper that we wrote. So we just paste in this polygon. And then we have a script that cuts out from the master model all relevant geometry. So in this way we could easily collect the geometry we needed from all our 3 master models. And from the polygon, we also automatically generate a base, which looks like this. A honeycomb pattern to save some weight. And one of the hexagons we add a small brand, which uniquely identifies the plate and so on. We cut out the terrain and automatically solidify it and add it to our base plate. And by the way, you can see a cutout in the terrain over there. That is old church ground. There is no church, it's just the ground, but it's recessed into the ground. And you cannot represent the vertical slope in the terrain model. So we made a cutout and we put it in as a separate piece. Okay, so these are ground types, and they are extracted in 2D, but we just drape them on the terrain, and they receive their solidity and volume in the draping process. And also, the different ground types, they have a different constant vertical offset to the terrain. So the curb, which is the gray, it is about, I think, 20 centimeters above the terrain, while the grass is, I think, 30 centimeters above. So in addition to this color separation, we also get some kind of geometric separation between the various ground types. And the trees, they're just dropped straight down onto the terrain, as you can see here. And finally, we we paste in the buildings, as well as the roofs. And you can clearly see here, clearly see here that we have the roof solids and the building solids. They're completely separate, which is actually quite nice to have. So this is plate 11. It's about 1,000 solids in this state. And this is what we export to OBJ. So the final solidification of all these 1,000 solids, they take place outside of SketchUp. And in addition to this, we also add a small tolerance to the plate. So we cut off 1/4 millimeter. So when we then build up our final puzzle, there is some tolerance between the pieces. Okay, so this process here, it's repeated 40 times, and we get our complete models. And it could also be worth to reflect on how these solids are actually created. So when you think about it, almost all solids here, they are created programmatically from various two-dimensional inputs. So the roof planes gives rise to the roof solids and building solids. The two-dimensional ground types, they're solidified and receive their volume in the draping process and so on. So in the end, there were not much manual solid modeling in this project.
And we think that's a good general modeling advice. Keep modeling in 2D as long as you possibly can, and go 3D as late as possible in the process, as a general rule. So let's make this real. Making it real required lots of work. So many late night work hours, and things will go horribly wrong, because this particular example is the City Hall. And this is fascinating in its own right, in a way, but ultimately it's not aligned with the client's vision. So here you can see, by the way, the printing studio at Landskrona looks a little bit like this. You can see, for example, the different color tests. We did a lot of color tests to get the colors right, because there are so much things that happen between the screen and the final print, so you need to test it, because you can't rely on the colors of your screen to match those that are printed, even if you have the calibrated screen. And here is Stefan Persson at Landskrona preparing a very early test print, the very first one, I think. So lots of manual preparation, and you can see the printer here, but hard work eventually pays off. So here we are with the very first real test prints. You can note the bright colors of these pieces. They're bright like that when they come out of the printer. It's before they have been treated with cyanoacrylate and wax, which you need to do in order to make the colors come out and to strengthen the surface. And behind us you can see the 3D Systems Project 660 Pro that was used. So the print chamber is there to the behind us. And what you do is that you load a couple of OBJs into it, and you tell it to start working, and hopefully next morning something comes out. So in one night you can print 3 plates. So 3 pieces. So here are 3 pieces, and you can just stack them on top of each other, because it works like this, that it puts out very thin, 0.1 millimeter thick layers of gypsum powder, and then it builds on top of that. So you don't need support or anything. So this is a render of what it may look like. But really, in the print chamber, the whole thing is covered with white powder. So then you need to vacuum that out in the end. Here's the very first test print in our office. So I think perhaps we should take a closer look at what the finished result looked like. And so do we dare to compare? We have input and we have output. Let's look at that. Yes, we do dare to compare. It's too late to back off. There's already a slide telling us to compare. So let's do it. So here is the top ortho photo, or part of it. Input and output. So the lighting is a bit different here in our rendering, but if you look at the limits, the borders of the images, you can see it fits quite well. In fact, it fits very well. So let's compare again. Here is an aerial photograph of central Landskrona. And here is our model rendered from approximately the same position in space. See? Let's compare again. Let's look at the prints. So here we are, our friend, piece 11 in a SketchUp view. This is just SketchUp. And here it is printed. So SketchUp, print. So the digital model completed. Let's look at the digital model. We've just seen parts of it. Here is, well, let's start by hovering over piece 11 on a dewy, misty morning. And let's zoom out and re-render, and you get a bigger picture of what it looks like. Here is the inner city, rendered in V-Ray. Just a quick render. And here's the first image showing the completed digital model. This is a pure SketchUp export, shaded using all the same. So remember, it's 1.6 meters wide. It's a circle. So this is from the perspective. That's why you have this oval effect. And here's the same thing in a clay render. The finished digital model contains roughly 35,000 geometry groups. And here it is again, the whole thing rendered with materials. And it took us more than 1,000 man-hours to complete the digital model. And there are prints of this outside in the gallery as well. The physical model, it got completed as well. So let's look at the printed results. So the inauguration, exactly 2 weeks ago, not to the minute anymore, but to the hour, was in the Landskrona City Hall, and still there. It's a permanent public exhibition. And apparently we were not the only ones interested in piece 11. Here are the model makers assessing the results. And here is Landskrona Planning Director Johan Nilsson assessing future developments. He was very keen on pointing out all the places in Landskrona he wants to develop. And you can note here that the water is represented not in stucco but in acrylic glass, so it was laser cut separately in order to give those reflections, provide some life to it. A lot of spectators were there and they were interested in discovering details. What are these people looking at? Perhaps they're looking at the 15th century castle, or they're looking for a new apartment, or remembering their old place, or getting lost in the allotments that are like small mini gardens that we have in Sweden. So we can have gardens within the city called allotments. Or living the Swedish dream of conquering the Danish stronghold. Or perhaps they're looking for a train ride southwards to Malmö, Copenhagen, Berlin. So the thing is you need to put a lot of like fascinating little details inside there so people can discover. They love that really. And here is the entire 3D printed city model. Right now it is Sweden's largest public full color printed city model. But of course with sufficiently narrow criteria everything becomes a world record. So at Holygon we are cutting edge only in a technical sense. Because what, after all, is the point of being technically correct, yet failing to arouse an emotional response? So, the city modeler's task is to convey a certain feeling of home, even though the spectator may never have been there before. So, our ideals are readability, durability, beauty. That makes for a timeless model. What will remain of us once we're gone? Sites of interest. Beautiful things worth discovering. We at Holygon, we welcome collaborations, co-workers, commissions. So do get in touch and just visit our 3D studio in Siriköping, Sweden. If you it's right there in Scania. It's close to Landskrona, by the way. Or visit our website, holygon.com. Ladies and gentlemen, thank you very much for listening. Thank you. Okay, questions. Ask us anything. You had a question, right?
Yeah, well, the basic question was, how did you, I guess I'm a little bit confused yet. Maybe
Yes.
The scripts are
You're confused, so am I. That makes two of us.
How you connected all the various sets of data. So, for instance, the LiDAR data, with to create these planes. That seems very intriguing.
Yeah, so the question is, how did we have different input tracks. So, for example, LiDAR point cloud and digital elevation model, i.e. the terrain, and we also had the orthophoto. How did we make sure these aligned? What do you say, Anders?
Yeah,
Do you want to have a go at that? Because you do have to make sure they are aligned and are using the same coordinate system. Otherwise you will not be happy.
The terrain model and the point cloud, that's very easy because they were already in the same coordinate system when we got it. The only thing we did was we made a translation. So our origin is in the tower of the city hall.
Yes.
That's the only thing. But the orthophoto, we just manually laid it out in SketchUp.
Yes, we knew, since the orthophoto is very precise, we knew exactly how wide it was. And so we could we could put it exactly where it would be, because we had already imported the points which do have coordinates. The images do not have coordinates that are easily importable into SketchUp. We didn't use them. We didn't have to, because anyway, if you have this was how many pixels wide? A couple of million was like, I don't remember, say 100 million, I don't remember, a lot. You'll get maybe an error of 1 pixel of 1.6 kilometers. So that's acceptable, indeed. So does that answer your question?
Well, then going from the LiDAR is sort of this, it just represents elevation, but linking that data to, sort of a roof or...
Okay, the terrain, that's just skinning. So you have height points. And you take 4 of those, connect with lines and a diagonal, and you get 2 triangles. So that's just so you have points and you can get the skin very easily. The buildings, now you really want to extract the SketchUp faces. So you sample out a couple of points, maybe 100 points. And then you have an algorithm that kind of grows this selection. So you get maybe 20,000 points.
It grows until it doesn't find anything anymore, and then it shrinks again.
From these 20,000 points, you just fit in the script. You just fit a rectangle, and that is how you get. That's how you get a roof plane.
Yes, yes, gentlemen?
Does the city own the digital model?
Yes.
Yes, they do own the digital model. We were provided with the data and an NDA so the data was just, we just borrowed it, and they got the digital model, so they have the full right to use the digital model. Yes. Does that answer your question?
Yeah.
Yes.
Is that the intent, should new development come in, that you would just replace the plates with new ones? Or?
Yes, they could do it themselves, but since they need to produce new buildings, well, maybe they can, maybe they can't. They couldn't make the entire model. Maybe they can manage to make one piece. I don't know. Otherwise, they just call us. It was inaugurated 2 weeks ago, but maybe something has happened. A house actually burnt down while we modeled it. But it's still there, right? In our model. Okay, lots of questions. Let's start with the gentleman over there.
We do a lot of master planning models in our office as well, and I think one of the biggest problems we find is representing trees. We tried that method with showing like the kind of the mass of the trees. In your research, did you find any other way of representing the landscape?
When I showed you our starting point, the watercolor, I think that judicious simplification is the way to go. So you need this mild or sometimes not so mild idealization. So you want to stylize and make it idealized. And that goes especially for large models. If it's a small model, just one house, you can make it more, you can put more details and change the colors more, because the eye will still recognize the forms. But if you have like 5,000 trees, if they are too lively and the canopy goes like this, then it tires the eye. So these are really simple shapes. They're just revolved. So they're really simple shapes. Some are almost like a sphere, and some are like an egg shaped, and some have a slight variation. Lots of people, I was surprised, have been talking about the trees and saying like, I really like the trees. And why is that? I think it is because the architecture in itself is very blocky and very jagged. So you need a contrast. So you need this soft, like almost woolly thing. So we tried with jagged edges, but I didn't like it, so we didn't use it. Does that answer your question about the trees? Okay. So you need to get a contrast to the buildings. If you have very round buildings, perhaps you should use more jagged representation of the trees. Okay. Yes?
So you added in the train cars. Obviously, there was like a train depot or something like that. Did you add any other sort of like cars, people, anything else that kind of adds to the life?
Yes, we have in the final model we have 4 buses. We have about 70 railroad cars.
77.
77, and 2 ferries that goes out to the island in the strait. And we also have 1 giant airship. But that is the amount of
So you could you go out to the gallery, and if you can see the full color rendered, and then you can see if you can find all the 4 buses. Okay, they're visible. But this is a scale 1 to 1,000 model. So if you need street views, of course you need more entourage. But this is meant to be watched from like a kilometer above or something like that. So we can only use the big vehicles, and we used some of them, but we concentrated on the architecture and terrain. Yes? More questions? Matthew? Nicholas? Yes?
What's the approximate cost of printing, just the printing, say one of your city blocks?
Yes. So the question is, what does it cost to print the entire thing? So it's 2 square meters. I don't know what that is in feet. Is it 22 square feet or something like that? Something, I don't know. Don't quote me on that. That would be, the material cost is It's $10,000, I think.
Something like that.
Yes. But it used to be, well, anyway, it costs about $10,000, but the exchange rate go up and down, so it could have been half last year. But I think you have to double that because you need to prepare the print. Ideally, everything goes well, but even if it goes well, you need to import the OBJ, and sometimes you need to rotate it so it fits. And then you need to, upload it to the printer. You need to clean the printer and so on. So there's lots of manual work with that. So you can probably easily double that sum to get the cost of the material. So does that answer the question? Yes. More questions? Yes?
Yes. I'm always curious. It's a fairly expensive project. And what was the rationale the city put forward? Why did they want to build it?
So the question is, why did Landskrona city want to build the model? Initially they spoke a lot about like city planning and stuff like that, and you can use it for city planning, you can use it for shadow studies, you can use it for like showing groups, the city, like newcomers or whatever. I think the main reason, my interpretation is that Landskrona commissioned this model for the same reason that so many other cities commission city models, pure vanity. Look at our city, it's a great city, but their city is really a great city. It's not that big, but it has this charming variety of building types that made it quite a lot of fun to model. Yes, question?
So to piggyback on that, I'm an artist, so I'm asking from a different point of view, but this is a model of a city, but frozen in one moment in time, but cities aren't frozen in time. So, for instance, a house that burned down while you're modeling it, how do you deal with that during the process, and also what does that mean for the model after?
I'm talking all the time. Do you want to answer? Or should I?
Yeah, the model is updatable because it is 40 pieces, and if they build a huge house in the city center, they will just take away that piece and put it in their archive and print out a new one. So it's not extremely updatable. You cannot just put in a single house, but it's somewhat updatable, and their intention is to keep the model updated. That is their stated intention.
Yes?
I had to build a somewhat large model for the university I was at, and one of the things we didn't do is we didn't make it in segments. We made one big giant model, and what we didn't foresee happening is that once the model was made, every building, different college wanted that model to spend some time. So it went on at their location, so it went on a tour, and that ended up being the huge issue. So they now have a big model that we had to move from building to building. And is there any, do you think there's any future of this model being moved? In that case, it seems like the segments that it's in makes it easily transportable if it's going to make its way around on a tour of the city.
Yes, the question or the reflection was upon, how does the fact that this thing is divided into pieces relate to its movability and so on. Yes, sure. We designed a table. You couldn't really see it here. There's a good table, and I don't think. Yes, it's easier to move it because it's in pieces, and we also dabbled with the idea of putting the pieces on a kind of grid so that you could extract, because once the pieces are in place, and if you want to remove a central piece, you need to dig out, either you need to dig out all the other ones, because it could be hard to lift it up right down. But if you put it on a metal grid, then you could poke up individual pieces, even if they're far in. Okay? They're quite heavy, by the way. It's the same density as stone. So it weighs over 100 kilos or more. I don't know, 200 perhaps? Not sure. Yes? Question?
Well, I was curious about the printing material. You're using stucco or gypsum plus a binder plus, and then layered on with cyanide acrylate. Why did you choose this particular material?
I think we didn't. The Landskrona, the municipality, they decided on the printer. And they were inspired by the printers in Malmö, which is a nearby city. They have used this project, the stucco printer, for a very long time. So when we came into the project, the printing materials and the printer was already decided on.
Yes, and yeah, that printer is about maybe $60,000, but it might have been twice a year ago because of the exchange rate. I don't know the American prices.
But it has the advantage of being able to print in color. And you said all the roofs were, you could take off the roofs, so they were printed separately?
No, that was just the visualization. When we visualized, the groups, the roofs are separate groups because you need to be OCD with your layers and your groups. So everything properly layered, every layer properly named, because otherwise you can't find them, it's a mess. And when you got 100 layers with different kinds of geometry and so on, and you need to be able, for example, manipulate all the roofs and the roofs only. And if you haven't put them on a separate layer or named them in a specific way or have another way of extracting them from the rest, then it take a day to like find the 13,000 roof pieces and not have the houses go. For example, say you have, and this actually happened to us, we had an orthophoto and another orthophoto. And they were taken, so one part of the city belonged to one orthophoto and another to another part. And they had a seam. And for geometry and for ground times, no problem. For sampling roof colors, problem, because one was in the summertime and one was in the wintertime, so the colors were different. So what we did was that we selected all the roofs that belonged to the one orthophoto, and then we made a small script, like less than 10 minutes or something, through which you could change the saturation, hue and lightness of those roof's colors, so that to match the original or the orthophoto that we wanted as the reference. Okay, if that answers your question. So you really need to be very organized. Yes, question?
Have you thought about scaling it up? If it's been successful, as you can talk about making one of your blocks, a meter and a half. Like, have people asked about seeing an even bigger, closer up version of what you've done? And how does that factor into the detail you build in the model?
Yes, can be so. Okay, I was going to say.
Yeah, when it comes to detail, I think what mainly decides the level of detail is the amount of time. So we are concentrated on the roof. So if you start to dabble with the facades, then you easily double the time it takes to produce the model.
And there wasn't data for that here. No. But here, you see that's a town hall, the council hall. And it's much larger. That's scale 1 to 200, so it's much larger. It isn't finished there. The printer gave up midway. But so we made another one. So yes, you can do that, but then you need to add more details, and then you need perhaps an even better point cloud. So I think the takeaway is that scale really matters, and you need to adjust the details and what details you use to the scale. Yes, if you just add 20% more details, you can like add a couple of months' work. So you need to think about that. Which details really bring a sense of scale? Yes?
Obviously, you researched this. What would be your choice of material to print? Some kind of polymer instead?
No, I think they made the optimal choice. This printer is excellent, really excellent when it works. It's not entirely reliable, and they actually have problem printing the model. But when it works, it's really, really, really good. And we were impressed and actually surprised over the quality.
How much cost to say polymer, like polymer?
I've actually no idea.
Yeah, you can do quick like tests with plastic, but the plastic 3D printers, the surface tends to look like something that came out of one of those, candy machines. You put 50 cents inside and then you come with this thing. People love 3D printing because they feel powerful, they've made something and it becomes physical. So they don't really care about quality in that way. So people wouldn't, even though the shapes are nice, people don't, I've never heard anyone who bought, they don't buy, they're giving away all the things down there in the Knowledge Cafe.
Well, that was the request. We made them before.
Yes. No. But you understand what I'm saying. You don't see it in Walmart. You don't see a 3D printed thing that made with MakerBot or something. That's for quick testing at home and so on. But if we hadn't used colors, then I think you could have printed it. If you wanted it monochrome, then maybe what's the name? Porcelain would be. Then it would have looked something more like this, perhaps. And with a separate water in something else. You can print in ceramics. That's
So you can't print color with polymers. You cannot choose different.
I don't know. Okay.
Go back to that image that you had before.
Which one?
Before you just rifled through all
monochrome.
little pieces and papers on the model.
I'm not sure. This one?
The one with the color test. The color.
Okay, the colors. Yes. What's your question?
Why are there sample colors and materials and paper shown in that photo? Okay, you see swatches of the materials. Swatches of materials and keep going. Blocks next to it. There. So what are we looking at?
So the question is, what are we looking at? So we're looking at a variety of things. Some failed prints. You can see the failed City Hall there. You can see some successful prints. You can see, is there a pointer or some sort? Well, you can see to the right, I'm doing the same thing as you. To the right, you can see 6 similarly looking city prints, and they are of a block or a couple of buildings, and they have been treated in different ways. So wax, double wax, cyanoacrylate but no wax, and so on, in order to compare the feel of the surface. And then there are papers. One of them is just the map of the 40 pieces. And then to the left you see the color samples. So with the material test 1, 2, 3, 4, 5, 6, in order to get a really good global color scale. Does that answer your question?
It does. So the water is actually done with paper?
No. The water is done, we exported at DWG so that the laser, the acrylic glass company could laser cut the water because we wanted the reflections. Okay, good.
We should also say the material test is very important because it looks nothing like on your screen. You really need those in order to understand.
Yes. The way the colors look, the colors that look good in print, if you put them on screen, they look bad. They look bad.
I'm a graphic designer. I get that all the time.
It soaks into the surface of the dish. So a very, very bright color may look more muted.
Yes. Thank you.